To assemble the clutch for the Triumph Trident, it's a 7-inch Borg and Beck clutch, although the clutch plate is slightly modified. You need to have a little bit of care when actually making the assembly. One of the things you need to do is to make sure that the clutch will fully disengage when you pull the lever in. Now, I have a standard setup, so it has a clutch lever on the handlebars that has the pivot point 1 inch from the cable point, and there are levers available that will actually increase that distance to, I think it's 1 1/8, might be 1 1/4, that gives you slightly more pull, so that you get slightly more disengagement on the clutch. According to the specifications, the clutch needs to be separated from the pressure plate or the back plate by 35 thou, and the 3-ball and mamp setup that is actually on the primary chain case gives you roughly that amount of pull. It'll actually give you more, but I measured the length the cable moves, clutch cable moves, when you pull the lever in, and it comes in about 0.55 of an inch. So what I have done is mark the case, and I've set a dial gauge such that when I actually push the lever to approximately that point, we have moved 0.9, maybe 0.9 of a millimeter, which is 35 thou. So as you can see, it's all reasonably marginal. Now, one of the things that I do with my clutches is actually measure where that release point on the clutch itself is, and having got that measurement, I can then make sure that I've got sufficient release to make the clutch work as required, and I will show you how I do that. One of the things we should talk about before we get there is the clutch plate itself. This is an aftermarket plate that actually has a thicker area or thicker friction material. So a lot of the plates come in and they're approximately 0.6 of a millimeter thick, and it has a wear limit of 60 thou, so under 60 thou under that. This actually has a thickness of 7.6 millimeters, which is that little bit thicker, and should actually last a little longer. With a clutch lever that has a pivot point to center of cable distance of 1 1/8 of an inch, you get a slightly more pull on the cable. 6.25 inches rather than 0.625 inches rather than 0.5 of an inch, which equates to, from the 1/8 of an inch position to the cable fully open position, of approximately 0.75 of an inch. So I've set the gap to be 1/8 of an inch. I've made a mark at the 0.75 of an inch. I've set the dial gauge to 0, and this one beats thou, and I'm going to pull this until we actually get to the mark, and I'm actually reading 40 thou. The implication of that is that that's 5 thou over the 35 thou as required by the Borg and Beck clutch to release, so I should have enough movement. So I'm going to buy one of those clutch levers at 1 1/8 of an inch from LP Williams. I could take the one off the Norton because that's where I measured it, but I think I want to keep that there. So the main body of the clutch is the back plate, and this one is from a T160, so it has the starter ring incorporated into this plate, and that will enable me to have a electric start on my bike. In the center I have a tool that is used to help align the clutch. Now I would prefer that it actually was properly centered in here, but I found it doesn't make a lot of difference. Then the clutch plate fits in with the shoulder down, and that sets in there. The next part is the spider, and they do tell you that it is actually marked because these are balanced in the factory. There we go. So the spigot actually aligns the clutch plate to the spider. Then the spring. This is a dished spring, and it points upwards so that the rim on the spider is actually pushing against the back of the spring, and of course the outside plate sits on top. Now there are some dowels, and they are spaced 120. There we go. And then all the little nuts. Now I'm not going to fully assemble this yet because there's other things that I want to do prior to doing that, but there's, I think, 12 little bolts, and of course between each pair of bolts there is a tab washer, so that once this is all put together you fold the tab washers up and it holds it all together. Okay. I have cut some paper strips and actually laid it in every other space, so there's 6 of these, and then we will replace the pressure plate, clutch plate, sorry. Okay, and then the spider, okay, and the spring, and then now we will fit all of the nuts, and I'll be back when that's done. With all the 12 nuts done up, the paper is now trapped and should obviously not come out. These will be used along with the pull rod to actually measure where the clutch releases and whether it releases just on one side or is reasonably consistent all the way around. And you can adjust various parts within the clutch to achieve that consistency, and you will be able to measure how much lift you need to actually release the paper, which should give you enough clearance to be able to change gear. Here is my setup to measure the release point of the clutch. I've got the clutch pull rod in with a spacer, and then the actual adjuster nut turned the other way up, so I got a nice flat area and a flat area at the top of the clutch nut with the oil seal taken out. What I also have just a little bit of free play there, so I know that I'm not pulling on the clutch yet, and of course all the papers are tight. And what I'm now going to do is, holding this as rigid as possible, is actually apply some tension to the clutch pull rod. So that is about 25 thou, and they're all still tight. Trouble is that's not exactly flat, but oh, that one's loose, that one's loose, that's a sort of loose, that's not, that's definitely not. It's just about 40 thou. That's still, oh, that's starting to come loose. That's starting to come loose. That one's not. That one is. That one is. And that one's almost out. Okay. So what I'm now going to do is to take it apart. I should slacken that off. So I'll take this apart. and dismantle the clutch, rotate the spider a little bit, and put the papers back in, and try again. The pressure plate in the inside the clutch has been rotated 120 degrees, although the outer plate and the spring has been kept in the same position. I've put marks. I've now retightened down all the little bolts. These are 10-32s, which are 3/16 basically. They need a spanner that is slightly larger than 5/16. I'm not sure why. And this is a spanner that I have used for many years, and I filed down the jaws just slightly so that it would fit nicely. Socket doesn't seem to fit a 5/16 socket AF. Right, so the idea is, so now I've made sure that I've got 5 thou of clearance on the pull shaft, is now to apply some torque. We'll go, as I've got 5 thou clearance, we'll go to approximately 25, which is applying 20 thou of pressure. Now, one of the clutches I did recently actually released at 22 thou, but I'm pretty sure this one's going to be quite a lot higher. So that is 35, and that one's still slightly tight. It's loose. Right. So I have at 35. Most of the pieces of paper are loose. That one is sort of loose, so let's go up very slightly. So that's about 36. That's loose, that's loose, that's loose, and that's loose. That one's still tight, and that one's loose. So go up just slightly more. Right, so that's just come in loose. That's at 40. The specification for the amount of movement that you need is 35. So that's still just slightly out. So I shall rotate that, because the two over here were not easily loose. The two, I shall rotate the inner, the pressure plate, another 120 degrees and see if that moves that around. And if that doesn't help, then the next thing is to move the top plate. because of course, or the spring, or both. The top plate and the spring set the pressure, and all things being equal, they should be the same all the way around. They're obviously not. So I'll come back when I've got to the next stage. So the reason for rotating the pressure plate 120 degrees is that the spring actually runs on this raised surface, and obviously as the pressure plate is pulled up, it is actually flattening the spring out slightly. So there have been instances where this raised portion is not actually parallel with the pressure plate itself, usually not very far out, but you can, by moving this around, if there is a spot that's slightly higher, you can actually find a position where the clutch is releasing freely and in parallel. The reason for that, or the reason why you want that, is that that is the least amount of clutch drag and the least amount of lever that you will have to get a nice gear change. The spring is actually set up such that the dish is upwards, and I have a mark to actually realign that in the same position. It may be, of course, that there's some difference in the tension around the spring, and in worst case situation you can replace the spring if that's what's causing it. Another issue is the spring actually runs on the inside of the outer plate, and it could be that that is not parallel with the clamping points, so we will actually line that up as well. Now I have a mark here which actually shows where this resides. I need to, there we go, to line that up. So I'm only actually changing one thing at a time. I'll now go and put all the little screws in. Is that right? No. So that's better. The dowels were actually in the screw holes rather than in the dowel holes. When I tighten these up, or when I loosen them, I do them 1/2 turn at a time, so that the pressure plate moves up and down together. With the tension set to 35, I now, and the pressure plate round to 40 degrees, I now have play on all of the paper. That is a good sign. I am going to leave it like that. I'm going to deassemble the clutch and then put the tab washers in, new tab washers, and then retighten it all and check it one last time, and that will then be ready to go into the bike. I have disassembled the clutch, ready to put it back for the final time, hopefully. One of the things that you need to do is to make sure all of the rivets are tight. I've never known one to come loose before, but I know that they do come loose on the shock absorber, and it doesn't take very long to make sure that this is all solid and ready to put together. The clutch parts have all been marked with paint, such that it will go back the same way as it came apart. There we go. And I've done a little bit of modification to my measurement system, in that the cap that goes on the top is flat, so that even though this can move about slightly, it doesn't make much difference to the measurements. And I'm now ready to put it back together. I am going to fit the tab washers this time, and I spent a few minutes bending the ends up so that it's easier to get a screwdriver under when you want to turn the tabs over. I should say, when I actually tighten these down, I actually go half a turn around, and I go around and around and around to bring the pressure plate down smoothly and evenly, to hopefully avoid warping the top plate or any part of the clutch. I have installed the tab washers and tightened down all the little bolts, and reset up the measurement system so that I have approximately 5 thou of clearance, so that I know the pull rod is not in tension. You'll see that I've actually got a nice flat on the top of the cap that's covering up the screwdriver slot. One of the other things I'm going to do, because I have a couple more clutches to actually service at some point, so one of the things I think I'm going to do is to actually weld on a clamp there and there, so that I can hold the clutch down firmly onto this steel plate. But we've now got to a position. Oh, the other thing I should mention is the thickness of these pieces of paper is approximately 4 thou. I don't take that into account because that actually gives me a little bit of leeway. So what we're now going to do is just check to see where the release point actually is, having taken it apart and put it back together. I really must buy a correct size spanner to fit this nut. Not that it's been an issue in the past. So that is now approximately 25 thou because of the 5 thou initial start. That one's loose. That one's loose-ish. That one's definitely loose. That one's loose. And that one's loose. So we actually have a clutch that should work in the bike. We'll go up another 5 thou, just to see what happens. Yep, that one's coming out. That one's coming out. That one's coming out. It's slightly tighter, but it's okay. You obviously need to get them all the way out. That one came out easily. That one came out. And that one came out. So I've got a clutch set that is released at 30 thou. 30 thou. So that I believe is I'm quite happy with. I'll just make sure that all the little nuts are all the little bolts, sorry, are actually tightened down, and then fold over the tab washers, and we'll go on to looking at installing it into the bike. With the clutch ready to go into the engine, I have applied a very light amount of oil to the clutch hub, and I have fitted the pull rod, and basically this sort of slides in like that, and yeah, it of course is quite close to the wall, because of course you need to be able to apply the electric start. So right.